So hello friends, in this video we will be solving Codechef starters 180 problems A to D. So the problem statement is CodeMet. The problem statement is CodeMet is an annual programming competition organized by the Mathematics and Computing Society at IIT BHU. Last year the event had X participants, while this year it attracted Y participants. Determine whether this year's event was more successful by checking if Y is greater than X. If it was more successful, print yes, otherwise print no. In input format, the input consists of two separated integers X and Y, where X denotes the number of participants last year, Y denotes the number of participants this year. In output format, we have to simply print yes if this year's event had more participants than the last year, otherwise print no. You may print each character of the string in uppercase, or basically you can print your output in any case. Multiple options are shown to you to explain you that it's not compulsion that you have to print in all caps or all small. Then constraints are X is in range of 1 to 1000 and Y is in range of 1 to 1000. So if you will try to understand, the problem statement is very simple. You are told that IIT BHU is organizing a particular event related to mathematics and computing. Now in this event, last year X participants were present, and now this year Y participants joined, or let's say attended the event. So we have to determine that are the number of participants which are attending event this year larger than the previous year attendance, or if it's lesser than or equal, then you will be printing no. So the answer would be very simple. First you will take two variables X and Y, and then you will take value of X and Y from the user input. Then here I am using ternary operator. You can also use if else as per your own preference. Now I am saying if X is lesser than Y, that means if number of participants which attended the event last year were lesser than the number of participants this year, then I will print yes. Else, if number of participants last year were greater than or equals to the number of participants this year, then we will be printing no. Now simply, if you will submit this one, it will work. Yeah, I hope everyone understood. Let's move to the problem number 2. So the second problem is maximum ones. In this problem, you are given a binary string S of length n consisting only of characters 0 and 1. You are allowed to perform at most k operations on the string. In each operation, you can choose an index I, where I is in range of 0 to n minus 1, and update the character at position I as follows: Si is equals maximum value of Si comma Si plus 1. Here the maximum is taken in the numeric sense, that is 1 is considered greater than 0. This operation essentially means that if Si plus 1 is 1, then Si becomes 1 regardless of its previous value. Your task is to determine the maximum possible number of ones in the string after performing at most k such operations. In input format, the first line of input will contain a single integer t, which is the number of test cases. Then for each test case, the first line of each test case will contain two integers n and k. N is the number of characters in our string S, and k is the number of time we can perform the max operation on Si and Si plus 1. Then in second line of each test case, we are given the string S of length n. In output, we have to print the number of ones, the maximum number of ones that we can achieve after performing the k operations on the string. Then we are given a sample case, and constraints are t is in range of 1 to 10 raised to power 5, n is in range of 1 to n, and k is in range of 0 to n. And in our string, we would be having only two type of characters, 0 or 1. Let's try to understand the problem statement. So in this problem, you are given an integer n, which is the number of characters. Then you have another integer k, which is the number of operations you are allowed to perform. Then in second line, you are given the string S of length n with all the characters 0 or 1s. Then you are told that the operation which you can perform k times is Si is equals max of Si comma Si plus 1. That means for any character at ith position, we can upgrade that character to the maximum of Si or Si plus 1. So this is just to confuse us, although simply what we have to do is, if you will try to understand, simply what we have what we want to do, we want to change our characters to 1. Do we care if I plus 1 is 0 and let's say I is already 1? No, because we want to achieve maximum ones. So we don't care if I is 1 and I plus 1 is 0, or let's say if I and I plus 1 both are 0. We don't care for that case as well, because if both are 0, we will still, our ith character will remain same in all these cases. So we only care when ith character is 0 and I plus 1th is 1. So instead of taking it as max or something, you can simply also say it in such a way that if I plus 1th character is 1, then we can change our ith character to 1. So let's try to understand that sample cases first, that why we are getting this 3, 2 and 3 output for sample case. So let's see the sample case. So let's say these are my answers. So in first case we are given 3 characters and k operations. So do we have any 0? Yes, we have this 0. So we can perform operation on this one. Then this 0 will be converted to 1 because the next character is 1. So we can convert it into 1. So in this case our answer will be 3. Then the second case is 3 characters and k1. So can we convert this 0 to 1? No, because the next one is also 0. We can only convert a 0 to 1 if next character is 1, because we were told Si is equals max of Si comma Si plus 1. So if both characters are 0, we cannot upgrade this 1 to 0 because maximum is also 0. But we can change this character to 1 from 0. And then can we change this now? No, because k is already 0. So we cannot upgrade the first one. So our answer will be 2 because we have maximum 2 ones. Then in this case we are given 3 characters, 2 operations. Can we change this 0? So then the third test case, now we are given 3 characters 0, 0, 1 and 2 operations. Can we change this 0 to 1? Yes. After changing this 0 to 1, can we change this 0 to 1? Yes, we can also change this one. So finally our answer will be 3. Now let me take one more sample case from my own side. Let's say instead of having 3 characters, let's say I have 5 characters, and let's say my other 2 characters are 0, 0. Now in this case, let's say my k is not 2, k is 3. So in this case, if you will try to figure out your answer, can we change first? Let's change these 2 zeros. Firstly we will be changing this one, and then we will be changing this one. Now we have performed 2 operations, so that means our k is 3. We are still left with 1 operation. Can we perform this 1 operation which is left with us on any of these 2 and get any benefit? No, we cannot, because we can only upgrade our ith character to 1 from 0 if the I plus 1th character is 1. Now there's no character after these 2 characters, these 2 zeros, which is 1. If there might have been any 1, then we could have changed that 0 to 1, which is just prior to the 1. For example, if there might have been 1 one character here, then we could have changed this 0 to 1, or else if instead of this 0 we would have 1, then we could have changed this one. So that means we can only change those zeros after which we have any 1. So that means all the trailing zeros are useless to us. So can we say we will start our computation from the last one in our string, because after this we have the trailing zeros, basically the zeros at last, which are of no use for us. So first observation is we have to start from the last one, the last occurrence of one character. Then other thing is, firstly we will find how many ones we already have in our string. Now first we can count our answer to be the number of ones in our string, then we can start from the last occurrence of 1 and keep on changing our zeros to 1s. Now for any 0 I don't need to check that next character is 1 or not. Why? Because when I am starting from this particular position and going to this side, so that means at whichever character I have reached, I have already changed the zeros next to this one as 1. For example, if I have reached at this 0, that means I came at this 0 after changing this 0 to 1. So we don't need to check the next character. Let's try to code this one. After writing the code you will get even more clarity. Let's take our two inputs, n and k. After taking inputs, we will take our string. Now we have taken our string. After taking our string, we can take two variables. One is our answer. Initially our answer will be 0 because we haven't counted any 1 and any occurrence of 1, and then we need another variable, last occurrence of 1. Let's call it -1 initially, because till now we don't have any occurrence of 1. Then we can run our loop till last character of our string, and we can check if string's ith character is 0. If ith character is 0, I can increment my answer. Sorry, if ith character is 1, then I can increment my answer, and after incrementing my answer I can also say this is the last occurrence of 1, because till now this is the last occurrence of 1 which I have encountered. The ith index is the last occurrence of 1. Then after coming out of this loop, I can run another loop starting from last occurrence of 1 till 0. Now I can say if ith character, if in my string the ith character is 0 and I have a valid k, because I can perform this operation only k times. So it shouldn't be that, let's say you have 6 zeros and you are changing all those into ones while your value of k is only 2. So you will change only those much zeros to ones as much you have the value of k. So if my ith character is 0 and I have a valid value of k, then I can say the ith character is 1. So these characters will be, test everywhere I have enclosed it in quotations. So if ith character is 0, I will change it into 1, although this is not compulsory for you. Even if you won't change it, still your code will work, because you don't have to check your string or anything later. You just want to figure out the count of answer. So we can increment our answer, and other than that we can decrement our k, and as soon as our k will become 0, then we will stop upgrading things. After coming out of this loop, now we can print our answer. Let's try to run it for the sample case first. Okay, I have use my variable in inappropriate manner somewhere. Okay, I forgot to write int before my last occurrence of one variable, so now it should be working. Yeah, let's submit it. Yeah, so let's move to the third problem. So the third problem is, shall we play a game? Alice and Bob play a game over n rounds starting with an initial score of 0. Alice takes the first turn. In the ith round, I is greater than or equals 1, lesser than or equals to n. The current player must either add or subtract 2 raised to power I minus 1 from the current score. As the game progresses, let x be the maximum score reached at any point, y be the minimum score reached at any point. Alice's goal is to minimize the final difference x minus y, while Bob aims to maximize it. Assuming both the players play optimally, determine the final value of x minus y after n rounds. Since this value could be very large, output it modulo this value. Then input format. The first line of input will contain a single integer t denoting the number of test cases. Then for each test case, we have an integer n, which is the number of rounds played. Now in output, we have to print a single value, which is the difference between x minus y modulo the value which we are given for modulus. Then constraints are t is in range of 1 to 10 raised to power 3 and n is also in range of 1 to 10 raised to power 3. Then we are given a sample case. First, let's try to understand the problem. So in this problem, we are told that there are two friends, Alice and Bob, and they are playing a game where n rounds will be performed in this game, and in each round, a person will add 2 raised to power I minus 1. In ith round, whoever is having his or her turn, he or she will add 2 raised to power I minus 1 to the initial or to the current score, and then it will affect the score. And another important thing is that initially your score will be considered 0, then the score will keep on changing as they will add 2 raised to power I minus 1, and at last we have to observe two values, x and y, one of which x is maximum score reached at any point. Basically, we have to observe that what was the maximum score reached while they kept on performing these moves, and what was the minimum score achieved while they were performing these moves. And then for this maximum and minimum, the difference will be our answer. And we have to consider that they are performing their moves optimally. Yeah, that's pretty much about the problem. Let's try to understand the test cases. Now firstly, for one second, let me move to the whiteboard. Now these are the test cases. First, let's consider the first test case, which is 1. Now if there is only one round, then there is no other possibility than that initially in 0th round, we can call it, or basically initially the score was 0, as we are already given in question. And then in first round, if Alice will add 1 or subtract 1, it won't affect much, because the difference between the maximum and minimum would remain same. If Alice will add 1, the difference will be 1 minus 0, which is 1, and if she would subtract 1, then it would be the difference between 0 and minus 1, which would again be 1. Then let's take the second case, which is for 2. So let's say if they perform 2 rounds. Now initially the score will be 0. Then in whichever direction Alice will go, Bob will also add 2 raised to power I minus 1 in that direction only, so that he could get the maximum, because Bob always want to get the maximum score to make the Bob doesn't wants to get the maximum score. Bob wants to create the maximum difference between the extremes, basically the minimum score and maximum score. So he will also add 2 raised to power I minus 1, which is in this case 2 raised to power 2 minus 1, that is 2. So this way he will be able to get 3. If he would have subtracted 2, then this value would have been minus 1, and the difference between minus 1 and minus 1 and 1 would have been just 2. But in this case the 2 yeah. So if we will take the second test case, which is 2 rounds, then initially the score will be 0, then Alice will add 1, or even if as we have already discussed, even if she would have subtracted, that won't create any difference. Then after that Bob will add 2 to 1 and will get 3, because the score in ith round will be the sum of previous score plus the number added in current round. So in this case, in round number 2, the value added will be 2 raised to power I minus 1, which is 2 raised to power 2 minus 1, that means 2 raised to power 1. So 2 will be added to the previous score, which is 1, we will get 3. Now if Bob would have subtracted instead of adding, then it would have been 1 minus 2, which would result into minus 1. Now the difference between two extremes would have been, the highest score is 1 and lowest score is minus 1, so difference would have been just 2. But in this case the difference is 3, as the difference between 0 and 3 is 3. So let's take another case. Let's consider 4. Now in case of 4, if Bob will take to 3, then what Alice could do? Okay, I'm directly taking. Now let's take the case of 3. In case of 3, if Bob would, let's first consider this same case only. Let's say in this case of 3, Bob would have added 3, and what Alice could do? Alice could add or subtract 2 raised to power 2, which is I minus 1. So 2 raised to power 2, 4. She won't be benefiting from adding 4. Instead, she would subtract 4. But now in this case, it will give us, if she would subtract 4 from the previous score. Now that means if she is giving 3 minus 4, that means minus 1. So the two extremes are 3 and minus 1, which will just result into 4. Now Bob won't be doing it this way. Instead, what Bob will do, after Alice have added 1, now Bob won't be adding this time. Bob will be subtracting the 2. So 1 minus 2 will result into minus 1. Then after this, Alice will add or subtract 4. So in this case, Alice will add 4, because minus 1 plus 4 will result into 3. So the two extremes would be minus 1 and 3. But if she would subtract, then it will be minus 5 and 1, which will result into even larger answer. So she will make it 3. So in this case, we will get answer 3 minus 1, that is 4. So first, let's make two important observations from this. let's take two important observations. So our observations are, answer will be at least 2 raised to power n minus 1. Now for any case, for 1 the answer is 1, which is 2 raised to power n minus 1. Then for 2 the answer is 1 minus 1, which is 2. Now this is again at least 2 raised to power n minus 1. And for 3 the answer is 3 minus 1, 4, which is again 2 raised to 1 minus 1. Now don't consider it in such manner that the answer will be always 2 raised to power n minus 1. For example, let me take that case as well. Now let's say if there is 4, let's say if there are 4 rounds, in that case first Alice will be adding 1, then Bob will be subtracting 2. We will be discussing that why Bob is subtracting and why Alice is adding. First let's consider it this way, then we will consider the other possibility as well. Then Bob is then Alice is bringing it to 3, and then Bob is again adding 2 raised to power and I minus 1, which is 2 raised to power 4 minus 1, that is 2 raised to power 3. So basically he is adding 8, that means that total sum will result into 11. Now in this case answer will be 11 minus 1, that is 12. Two extreme ends are minus 1 and 11, so answer is 12. Now in this case it is not 2 raised to power n minus 1, that is 2 raised to power 3, so the answer is not 8 this time. Let's figure out what we are doing. First observation should be which you should make is, answer will be at least 2 raised to power n minus 1. Why? Because the last move will be 2 raised to power n minus 1. So from whichever value we are adding or subtracting 2 raised to power n minus 1, so the difference between the last second move and last move is directly 2 raised to power n minus 1. Then the second observation is, there are two different kind of cases, one in which Alice takes last turn, another in which Bob takes last turn. Now please pay attention to this second observation, this will give the whole answer to us. So let's first let me remove this one. So if you will try to think, what they are doing is, now if Bob is having the last move, what would Bob like? Bob will want to keep the data as much as spread up as possible. Now let's try to understand this thing using a visual diagram. So let's say Alice and Bobs are trying to reach the best solution. So let's say in first move Alice goes to this direction, let's say Alice goes to this direction, then now Bob will try to go even more to this direction to increase the extremes. Then in response Alice will again try to bring these values back here. So can we say they will keep on doing this thing unless we reach at the last value? Now can we say our solution depends upon only this thing, that who is taking the last move? Now let's say if Alice is taking the last move, then can we say this last move will be our whole answer? Because if let's say Alice incremented it till 16, then Bob took it till 32. So whatever previous values are, because we all know that for any number if we are computing 2 raised to power n, then 2 raised to power 0 till 2 raised to power n minus 1. These whole values will be summing up 1 lesser than the 2 raised to power n. So whenever 2 raised to power I minus 1 or let's say 2 raised to power n minus 1 is computed, so all the previous ones were smaller than this one, and these both Alice and Bob will keep on going up and down. That won't affect our answer. The only thing will be that in last move Alice will, if let's say Alice is coming from here to here, or let's say Bob took it this side, then Alice is coming now. Alice is going from here, let's say till here. So the whole answer is, now the two extremes are basically this value only, the value which we added at this particular moment. So can we say the answer will be 2 raised to power n minus 1 only? But another case is, now let's say the Bob is having the last move. Now if Bob is having the last move, in whichever direction Alice is going, now Bob will try to increment the extreme, so Bob will add into this one only. Now if you will, let's say this is not the case, this only these much are arise, so this is our 2 raised to power n minus 1. Let's say I have drawn it a bit smaller, it is, let's increment it. So can we say if Bob is taking the last move, our answer will be 2 raised to power n minus 1 plus 2 raised to power n minus 2. Why? Because in every move, if Alice knows that the last move would be taken by Alice, then she will start from a particular value and go to that side only, in whichever side she gets the best solution. So in whichever side she is getting the best solution, if she will go to that side, basically to this extreme, to one extreme, in whichever side she is, to the other one, so that will give her the difference only, that particular move, that particular value which is added, because in every move she will try to come back from the extreme. Bob will always try to go to extreme, so she is coming back from some extreme, and because this is the largest value till now, this will go till the extreme. And but if Bob is taking the last move, then Alice will come from an extreme to another extreme, and Bob will add to that extreme. That means Bob will add 2 raised to power n minus 1 to 2 raised to power n minus 2. So can we say, if Alice is taking the last move, that means if last move is odd, if the number of moves is odd, then answer will be 2 raised to power minus 1, else answer will be 2 raised to power minus 2. That's the basic logic behind this problem. Let's see the code. So first I am taking the t test cases, then for every test case I am calling my function result from the function main. But before that, what I am doing, I am creating a sieve. Now if you want to be creating this sieve is nothing else than simply the powers of 2. So I am using this function, it's pretty basic function. I am calling it on base 2, as you can check from here. So from my main function, I am running a loop from 0 till sieve size. Now sieve size is basically 1001, that is 1001, because I want to compute 2 raised to power starting from 0 till 1000, because our n can go till 1000. Now if you won't be storing them initially, that will cause you a trouble, because if you will keep on computing powers again and again for every input, your time complexity will exceed. So that's why we are creating, firstly we have created a global vector sieve, and we took a variable sieve size 1001. Why we are taking this exact value 1001? Because we are given n will go till 1000. So we want our sieve to have indexes till 1000. Then we are taking this mode, because we have to print the answer in mode, as our answer will be large enough. So After this, we are storing the powers in sieve. Then we are calling our result function. Result is simply taking the input n from user, and then in answer it's simply checking if n is odd. That means if Alice is taking the last move, then our answer will be 2 raised to power n minus 1. Now I am simply calling this sieve, simply checking the n minus 1 index from my sieve array, which will give me the 2 raised to power n minus 1. Then I am printing it modulo mode, as we are already given in question that print the result in modulo mode, otherwise your integer, your long int won't be able to store these huge values and you will get an error. Else my answer will be else Bob will be taking the last move. That means Bob will get the answer, the last move taken by Alice plus the last move taken by Bob. So I will compute my answer depending upon the condition that who is taking the last move. Then I will, at last I will print my answer. Let's try to run this one. So let's try to submit this one. It's working. Let's move to the next problem. So the fourth problem is array operations. You are given an array A of n positive integers where n is odd. You will perform the following operation repeatedly until one element remains. Choose any 3 consecutive elements in the array, say ai plus 1 and ai plus 2 for some valid index I. Remove these 3 elements and replace them in the same position with a single integer equals to maximum value of ai plus 1, ai plus 1 or ai plus 2 plus 1. Basically 1 added to the ai plus 1 or 1 added to the ai plus 2, maximum of all 3. Then your task is to determine the maximum possible value of the final remaining element if you perform the operations in an optimal order. Input format, first line of input contains integer t, which is our number of test cases. Then in each test case we are given an integer n, which is the number of elements in our array, and then in last line we are given n space separated integers. Then in output we have to print the maximum possible value of the remaining element after performing the operations optimally. So we want to perform the operations optimally and increment our last remaining element as much as possible. Then constraints are t is in range of 1 to 2 10 raised to power 5 and n is in range of 1 to 2 multiplied by 10 raised to power 5. Elements are in range of 1 to 10 raised to power 9. Pretty much standard, everything is pretty much standard. So let's look at the sample cases. First let me discuss the problem statement. So the problem in this problem statement we are given that we will be given an integer n, which is the size of our array, and this n will be always odd. Now this is another this is important observation. When we will be discussing the problem, I will discuss why it's so important. Then we are given n positive integers in which we can perform a particular kind of operation. Now this operation is choose any 3 elements, then remove these 3 elements and replace them by maximum of either the central element or the first element added by 1 or the third element added by 1. Now in first and third element, be careful, observe this carefully. If you are taking first or third element, then you can add 1 with that. You can take 1 more than a1, or let's say ai, or 1 more than ai plus 2. But if you are taking ai plus 1, then you will be taking the as it is value. So if ai is maximum, you cannot increment that. If ai plus 1 or ai plus so if ai plus 1 is maximum, you cannot increment that one. You can take AI incremented by 1 and AI plus 2 incremented by 1, but AI plus 1 you will be taking as it is, and you have to maximum the last remaining element as much as possible, because elements will keep on deleting. You will keep on deleting 3 elements and replacing that by 1. So at last you will reach at one point where you will be having only one element in your array, and when you reach at this point, you want your element to be as large as possible. Let's check the sample cases. So these are our sample cases. Firstly, we are given, in first test case, we are given one element only, which is 6. So if you are having one element, you cannot make any changes or you cannot do anything. So answer will be as it is 1. So let's say in our first case, our answer will be 6, as our element will remain as it is, because there is only one element. You cannot add something, you cannot increment something, you cannot do anything. In this case, we are given 3 elements, so we can replace these 3 elements. We can replace them with, now since you are having 2, 2 and 2, these 3 elements, you can remove them and take maximum of, now as all the 3 elements are same, so a maximum of AI plus 1, that is 3, and AI incremented by 1, or AI plus 1, which is 2, or AI plus 2 incremented by 1, which is again 3. Now maximum of them will be 3, so our answer will be 3 in this case. For these 3 elements, the answer will be 3, because the last remaining element will be 3. Then for this case, we are given 3 elements, 1, 2 and 1. In this case, if we will remove the elements, now you have 2 choices, both leading you to same answer. Either you can increment AI by 1, which will lead to 2. Either you can increment, basically all the 3 are leading you to 2. You can increment your AI plus 2, which will also become 2, or else you can use your AI plus 1. Now, as we discussed previously as well, we cannot increment our AI plus 1. Now in this case, we cannot say answer is 3. Answer will be 2. Let's take another case, which will give you even better clarity. I hope these ones are clear. Let me remove this one. So the other test case is this one. Now if in this case, because till now what we are thinking, what we are trying to do is, firstly, what we are trying to do is, we are taking the largest element and removing the rest of the elements and keep on incrementing that one. So let me add another value to this one first. So let's take this sample case. In this case, as we have observed the previous 3 cases as well, can we say that we are just taking the largest element and keep on removing the other elements and incrementing that one? Yeah, we can. Sorry, we took 6 elements, but now let's check this sample case. If we take 11, 3 and 7 and increment this 11 and remove these 2. So as we were told that we can take AI incremented by 1 or AI plus 1 or AI plus 2 incremented by 1. So we are taking AI incremented by 1 and removing these 3 elements. So now our array is 1, 2, 4, 5 and 12. Now let's say if we again take these 3, 4, 5 and 12. Now if I delete 12, 5 and 4. So basically I am deleting AI plus 1 and AI plus 2 and replacing them by AI plus 2 incremented by 1. so I can replace them with 13. Then I am left with 1, 2 and 13. Again I can do the same thing. I can replace them with ai plus 2 incremented by 1, which will result into 14. So our answer will be 14. Now if in this case we will look carefully. So basically what we are doing is we are deleting 2 elements every time and incrementing our largest element by 1. So can we say our answer will be largest element incremented by the size of array divided by 2, because the number of deletions, if you are deleting 2 elements every time, so in case of 7 elements the total time deletions will be performed would be 3, because you are deleting 3 elements and adding 1. So can we say we are removing 2 elements, because at last every time our array count is decrementing by 2. So that means we can say our answer will be maximum element plus array size divided by 2. But let's look at other thing. There's another catch in this one. So let's say my I is, let's take it 7 only, but let's say this one is at this position. Now in this case, if you will try to do the same thing, you won't be able to do it. Now let's say I am deleting 11, 3 and 7, or you can take it other way as well. You can start from beginning as well. I am deleting these and incrementing my 11 by 12. Then I am taking 4, 5 and 12 and replacing them by an incremented version of 12, 13. So now can I increment my 13 further? No, I cannot. Now in this case my answer won't be 14, it will be 13 only. So let's try to figure out why this is happening. Because whenever there are odd numbers before your array, before your largest element, or let's say the odd number of elements after your largest element. Now if it will be the odd numbers before your largest element, then it will be odd number after your largest element as well, because there are the total number of elements in your array are odd. So if there are 7 elements, or let's say the 9 elements, or any odd number of elements, and one of them is our largest element, after this we are left with even number of elements. From these even number of elements, if the elements before the largest element are odd, then automatically, because if you will divide an even number into 2 sets, either these sets will be having both even number of elements or odd. So if you can check any of these, if the number of elements before your element are odd or after your element are odd, then your answer will be the largest element plus 1 incremented for every deletion, but not for the last one. So can we say answer will be largest element plus array size divided by 2 minus 1. Let's see the code for this one. So what we are simply doing is, first we are taking our t input from the user, which is the number of test cases, then we are running our loop t times and performing the result function. Now what this result function is doing, it is simply taking n from the user, which is the number of elements in our array, then it is taking all the elements in array with the help of user input. Then we don't need to say this one, that if n is 1, then we are printing b0, because that would also be handled by our function only. So we are taking a boolean variable LA even, which is basically checking that the items before the largest element, are they even or odd. Initially we will keep it false, then and we will take another long int type variable largest value, which will be -1 initially. Then we will run our loop and check if we are getting the largest value, then we will upgrade our largest value. So we are using this loop to simply let me add a comment here for your help. for better clarity, finding the largest element. Then after finding our largest element, we are simply checking that is the largest element having even number of elements before it. So now this is very important, taking the largest element and checking if this, because there might be multiple largest elements. Let's see in this case, for example, if you will just check simply that at which index largest element is, that might be problematic in some situations. For example, let's say I have 11 two times. Now let's say if I have 11 here as well, and let's say here's a 3. So in this case I have two 11s. This 11 has odd number of elements before it, but this 11 have even number of elements before it. So if you will simply take the index of largest element, then that might create problems for you, because in that case it might be that you took the index for this one and you are considering that there are odd number of elements before this. So we cannot increment it every time. For last time we cannot increment it, but because we have another possible value of 11, then we can choose this one and we can increment in last instance as well. So that's why we are checking that is there any largest element. After finding a largest element, we are checking by using this loop that is there any index where the largest element is present and this index have even number of elements before it. After this, we are taking our answer variable. Then we are saying if li even is equals false, that means if the largest element doesn't have any occurrence where the elements before it are even, then our answer will be largest value plus n divided by 2 minus 1. Minus 1 is simply decrementing the operations by 1, because in last step we will be performing the operation for deleting the two elements, but we won't be able to increment our largest value. Else, if li even is true, then if there are even numbers of elements before and after our largest value, then we can increment it on every occurrence or on every time when we are performing the operation. Let's try to submit it. Yeah, so I hope my solutions are clear enough to understand.